And I need to
at least
update
briefly.
I need to update the other ones with title pages because I haven't done that yet.
I mean, when,
I've
you're
just been
not
out, I've just been busy, so
completely being, yeah, exactly.
yeah. So I need
Super busy.
okay. All right. I think we are live, but I'm going to
Yep,
double check.
we are.
Okay, good. I want
All right.
to
There's the
get it
chat.
playing so I have the chat up in case anybody is in here and wants to chit chat with
Yes.
us.
I was gonna
Or
say if you want to handle that, that's fine. I'm
or if we're
also
just
at least
talking
gonna
to
keep it up.
ourselves, which is fine. Of course, it's not showing on. Oh, there it is. Okay, I got it. All right. All right, so let me turn this off. Okay, and then if you want to share the link, go ahead.
Absolutely on it now.
Okay.
I'm
There
just
we
posting on
are.
my page though.
What's that?
I'm just posting it on my page.
Okay. Yeah, go ahead. I'll give it a couple minutes since I didn't oh look, Lisa's here. Yep, chat is up. Okay, sweet. Welcome. Welcome. I'm gonna put as I'm saying it and then typing in the chat like a
Right. I was about to do the same thing. Like, hi everybody, and typing it.
hey
Oh wait,
everybody.
you probably don't
So
need
we're
both.
here. Um, I'm up in Alaska, and so this is it's fun after being on a week-long workshop with a photographer that some people might know, some people may not know, but Mark Adamus, he's an intense person. So I'm a bit frazzled and tired, but we're here. We're going to make it work. So it's a little lighthearted this week. We're going to talk about current events, kind of like what we saw last night in Alaska. And Tanya saw some stuff in Minnesota, which is worth talking about, and reverse shocks because there was some chit chat about a reverse shock that was saw in Glendale and it caused some confusion. So that's the agenda for today. And I got to show my Arctic Circle shirt because,
I
you
still
know,
have my jacket that has Coldfoot Camp on it too.
it's like you just gotta.
Yeah, gotta get something.
Yeah, gotta get something from the old cold foot camp, where all the rooms smell like diesel fuel and it's it's part of that whole
And you're
Alaska
squeezing
thing.
into a room because that's all there
Yeah.
is.
So it's fun and exciting. All right. So do we want to talk? Do you want to take the reverse shock thing first?
Yes, I would very much like to do that actually,
So
because that I
take it
feel like
away.
is probably the more and this is the chart I'm going to post. I know there's several other ones, but I'll be honest, this is the one I just have immediately at my disposal. So the first thing I want to clear up for especially everyone that was confused
Yeah.
about what was showing up, reverse is a not the best choice in words. The solar wind is radiating radially outward at all times. There are no, it's going in towards the sun or it's moving suddenly. The reverse is just maybe a bad word in this sense. So I like this chart specifically because it looks at it only in terms of solar wind parameters. We've got the temperature up the top, the density is the NP, the magnetic field strength of the interplanetary magnetic field is VT as per usual, and then VP is the velocity. The commonality in all of these. So we've got fast forward shocks, slow forward shocks, fast reverse shocks, and slow reverse shocks. This means there's fast and slow, and there's forward and reverse. As usual in science, we try to use simplified names, but often it can lead to miscommunication, we'll say. Notice in the similarity in all of these, the velocity increases in all of them. So for any shock to occur, generally the velocity is going to increase. That's just the expectation, and it's also kind of the physics of what forms a shock. In the fast shocks, so the first term, fast, not slow, all of the parameters decrease or increase in unison. So a fast shock involves all of the parameters increasing. Magnetic field strength increases, as does density and temperature. Whereas the reverse, which is where they are slow, or rather where they are decreasing, they are all decreasing in unison. So a fast reverse shock is instead a lowering of the temperature. It's less dense and it's less strong in its magnetic field, but they're all doing that simultaneously with each other. So clearing that part up. Now, likewise, you instead of fast, you can have slow. I like to think of this as the magnetic field is slow to catch up with what's going on. So for any slow shocks, the magnetic field strength is going to be inversely proportional to whatever happens with the density and temperature. So the slow forward shock, a forward shock is always going to be an increase in temperature and density. If it's slow, it means the magnetic field is actually decreasing when that happens instead of increasing with it. Likewise, with reverse shocks, where the temperature and the density decrease, the magnetic field strength is going to increase. So slow, the two parameters don't add up. So again, magnetic field strength and solar wind parameters, they don't align. One does one, the other does the other. If it's fast, they do the same thing. If it's forward, they're increasing. And if it's reverse, they're decreasing. Don't think of this in terms of physical, just think of it as words for these parameters. That's going to be the best way I can get that out. As far as Aurora is concerned, there's maybe a few types, or rather a few different things that might signify really different things happening to then figure out what's going to happen with Aurora as to whether an event's maybe ending or beginning. But in ultimate terms of thinking, it's not that important of a term. If you're just out trying to find Aurora, you're still looking for high BT, you're still looking for negative BZ for a while, you're still going to watch mags. The type of shock ultimately doesn't matter.
Well said. Thank you.
Any
So,
comments anyone want to add to that?
Yeah, I would say
no.
that, as far as the type of shock and why it matters, it's not specifically for Aurora. It really is for recognizing some of the features in the solar wind, like CMEs, and coronal
CHs,
hole.
which
Yeah,
in this
exactly.
case, pretty big
Yes,
example.
yep, that's where you're going to see them. So for forecasting purposes, as far as this is a big structure, it's coming, and if you know that it comes with a specific pattern of change in the magnetic field, which is BT, that's going to be helpful. Otherwise, you're still going to look for, as Christian said, BT, BZ, you're going to watch magnetometers.
So if
Yay.
we see those alerts in Glendale, which is cool that they're there, remember,
Yeah.
doesn't really mean much. Also remember to verify those shocks. That's going to be more important. Just because Glendale says there is one, does have false trips. So just make sure there's an actual shock occurring in the solar wind data. That's important. So from there, we can do a little review. I figured, and I'm leaving to Alaska tomorrow on that note. So Mary Beth's been gone all week, and I'm going to Alaska tomorrow, and then we'll be in Colorado the week after. So it's going to be kind of a rough month. So we didn't really want to get too deep into something, although we're 10 minutes in and I've already been explaining this for a while. So we can't not do that. But we
I,
figured just explaining current data. So if it's, let's say, the last maybe day or two as to what's been going on, and I figured we would start with that with solar wind data, as per usual, which from what most places are saying, what was Met Office, Tanya? It was like an erratic uh, connection with the CIR.
Yes, and transient cannot be excluded. So
Yes,
that was a
agreed.
mix.
Also, it appears to be getting dark and I'm turning gray. So sorry to everybody, but I forgot to turn lights on because it was bright just a second ago.
yeah, because it
Uh,
kind of looked interesting because it seemed like there was something there, like you were saying, like
yeah.
a
So in a normal CIR, especially, it's not going to generally be this strong for this long.
yeah.
The other thing I noticed was BX was not stable through most of that interaction. It was still in a towards position or a positive BX, but it wasn't all that direction. There were still moments where it was all in the Z direction, which is fairly uncommon of a kernel hole once that starts kicking in.
Okay.
But looking at the actually, well,
I
does
mean
this
that
does
kind of
this look
looks
like a
like
flux rope?
it looks flux ropey.
Yeah, it looks like a very rough southwest north,
That could
which, possible. The temperature doesn't really align with that, so I don't like that very much.
yeah.
And it's all towards which the kernel hole is supposed to be anyway. But it could be, again, like she said, we can't get out of transient. It's very possible that it's a mix of everything. So I like how Met Office phrased it. It was pretty funny, erratically connected. But the point was, oh, well, wait, to zoom back out. There we go. Point was, we had some very nice negative BZ last night. It got down to a bit below -10 for most of the night, with periodic jumps to the 0+ positives for a little bit of time before dropping back down. I know that Ohio even had a small chance, but with the overpowering moon and it just the magnetosphere wasn't quite cooperating with something like that. Oh, look, white screen, and now I have color again. This is I want to say the east or west Greenland, because I was trying to figure out the best magnetometer to use just to show off the substorms for the time period. The Norwegian one was a bit late, and then the East Churchill ones were a bit early. So I like being able to signify that we had quite a few actually that jumps where we expected more so almost sawtooth-like characteristics, maybe a bigger-ish one, and then a couple hours later another one. Looking at the AE index, I think that really kind of proves the point that that's not really what happened. It was very asymmetric and random almost. But you could see that in the Aurora. The Aurora would start brightening up and then dim away, and then brighten up and then dim away, and then it get really big, and then it dimmed away. But I will leave the visual aspects to YouTube. So if you want to go over what you saw,
Yes,
and
yeah,
I
we
can
could
keep
do
the
that.
screen up if you want to see anything.
Yeah, because basically, like he was saying, so this is what we saw in Alaska. So we'll start here with Alaska because Tanya also saw it in Minnesota. Um, we
We
did
can
a
we can start with Minnesota and kind
okay.
of
I was gonna say,
pass
let's go like,
pass the
yeah,
Yeah,
from,
time. So
yeah.
I will pass it over to
um
Tanya.
We'll
so
do this section of things
yeah,
first.
we do that
Yeah.
section. So there was a nice drop initially around 2 UTC, and instead of trying to break again, I think the solar wind was fairly all over the place in terms of BZ. It went for more of the steady convection pattern. Yeah, it was.
-7, yeah,
Yeah,
it
it's a
was
little
definitely jumping into positive numbers too.
different date, different date.
Oh,
It
that
was
wasn't the ninth?
it was a ninth, but it was a little earlier. So 3 UTC, I
Oh,
think.
yeah, we want to do like midnight UTC or something.
Yep.
Yeah, fair.
All these times, I'm just all over the place.
I know. I like how we're all in different time zones again too on that note.
Yeah, I'm in the more extreme one
Like
right now.
here to here, let's say.
Yeah, we are talking about fairly up and
Yeah, there
down
we go. Yeah,
BZ.
it was
Yeah.
still, look at that, bounce, bounce, bounce,
Yeah, but
bounce.
all that bouncing basically translated into more of the steady convection pattern. With a few breakups where Aurora would brighten, I could see auroral beads in the few rays, and even something that looked more like westward travel and surge going through at one point. But it just would not break and go into the usual life cycle where it's clearly growth, onset, where we see really bright aurora and tall rays, and then full expansion and then into recovery. So that wasn't happening. Aurora was just sitting there as literally that diffuse featureless arc green, and
Ugh.
it was going on. And I think the Glendale lab was calling for prediction, and again, conditions were right for the aurora to go into a substorm, into brightening phase. But for some reason, the magnetotail was not feeling it. It would destabilize a little bit, but would not go for complete depolarization, complete restructuring of the entire magnetotail. And we were waiting. I think we ended up waiting for about hour and a half to really see the best stuff. And we could see that, yep, something is happening. Oh, yeah, no, it's a
It's like
no-go again.
like what, 10:30s when things started getting pretty bright, would
Yep,
you say?
it
Well,
was,
my time,
yeah,
I guess.
yeah. So in UTC, we were talking about about 3 o'clock
Yep.
UTC
So this
time.
period then, yeah.
Yeah. So it was going, and kept going for just convection with a few brightening, but then it finally broke. And
Nice little
it
spike there.
was, yeah, finally it did something.
And then finally,
And it did not go away completely either. So the convection just continued. It was kept building up. For us, that was enough. I saw that usual, okay, yeah, it's brightening, it's auroral beads. I saw nitrogen fringe, which is apparently not that usual for bent latitudes, and I wasn't the
Oh,
only one who saw them in Minnesota, who saw the nitrogen fringe in Minnesota. So I
they
clearly
look so
wasn't
different when they're
hallucinating.
far away.
It looks very different. It looks very different. I would love to see it in Alaska, so I think I'm gonna have to go next year.
It looks
yeah.
like it's falling to the ground. When it's near overhead, you almost
Wow.
start bracing yourself, thinking the pink is just going to fall to you.
It's really cool. Yeah.
Yeah, but it was beautiful last night, so it was fun. And once it started going into kind of more pulsating pattern, that was enough for me, and we drove home. And then off it goes to
And then it
Alaska.
quiets, and then we get the Alaska section,
the
which let's see, what
Alaska
was BZ
section,
doing then?
because we
I mean, it
missed,
was still mostly the same thing. A lot of positives in this one
yeah,
too.
because we missed the that big spike, the big first that substorm that you see
Like
in
three, here,
because it was still light out
this
here.
bit.
Yeah,
When did you guys have sunset? What time?
6:15 ish, and then it didn't truly get dark until I don't know, about an hour later. It just seemed like it took forever to get dark.
So about five, so about 6, 7 UTC then.
Yeah. So we were waiting there. Mind you, like this is so like the whole story here. We've had this workshop and we've just been fighting with cloud cover and weather conditions and like in lackluster Aurora. Like we were up north of the Arctic Circle, where typically you will get aurora up there. Like you just will because you're at the source, really. It's the ovals there. But the time that we were there and the time that it was dark and clear, it was the time frame in the AE index where it was flatlined. Like it was a straight like northward pointing BZ. It didn't do anything. It was there. Like if you took a picture, it was that green diffuse nothing that doesn't do anything. But I was like, come on. And it just did nothing. So, and then we go into 3 days of cloud cover. And so last night was kind of like the last Hail Mary. I took the group, there were four of us, that the group that didn't fly out right away, and we drove 130 miles down to Denali National Park as like a last Hail Mary pass, and like hopefully we see something. And we did. It took a little bit of, patience. I could tell you it's like, hey, this will happen. And so we saw a really, really beautiful substorm out of this. And the one guy has never seen Aurora before. I pointed it out to him a couple days ago when we were at Sheep Mountain. And but it wasn't naked eye visible, it's camera visible. So, but he still thought it was cool. So he finally got to see a naked eye Aurora experience with the pillars and the stuff
Yay.
overhead. And he was just thrilled. It was great. And everybody got their shots, and we had to make a decision. Like we have a 3.5 hour drive back to Fairbanks on icy roads, and do we want to stay to try to catch another one, or should we pack up? They were all happy with what we got, so we made the decision to start making driving back. So we missed the second one, which would have been around midnight Alaska time, which was the one that my friend Laurel got a really great nitrogen fringe on. Like it was overhead. And like Christian just said, it was like kind of falling down. It looked like she has some really awesome video of it in her stories, but so I can't bring it up. I can't find it, so I can't bring it up on this computer. Because stories on Facebook are weird like that. Um, so she got, yeah, she was down in Delta Junction, so she got to see the that good stuff from the second one, but we were driving. And it was cool though, because we could see it, you could see the pillars and stuff like kind of like arcing overhead as I'm driving down this icy road, and then I'm like, pay attention to the road, not the aurora going on out there. So
And
it
that's
was
all this here for two,
yeah.
right? Said
Yeah,
around
so
midnight. Yeah.
yeah, so we missed that really good outburst, but it was good. It was a good experience for them. They got to see some really good stuff before flying home, and so it made me feel good, even though I was a bit nervous on those. There were spots on that road where I was like, I don't know, like the car was kind of all over the place.
I don't miss driving on icy roads. Glad you made it alive.
Yeah, so we're here, and I'll be here for another week. Christian's coming up here, so hopefully we'll have some more tales from Alaska to talk about.
The last thing I wanted to cover was just that there will be more coming. We've got now a
Yes, yeah.
southern coronal hole,
Yep.
also the same polarity, so it probably will have a similar effect given that so we got snap, right? So
Yeah.
at least snap for the northern hemisphere. So we're in spring now, so negative, which this hole is. Negative polarity is
It's
what we
yeah,
want. So
and
there's a possibility.
it's potentially slightly better position for us. We're still kind of below the equator of the solar equator, so
Well,
we are
let's do
seeing it.
this.
Yeah, we're seeing it in the in a good location. We are at -7. Yeah,
Yeah, it's not bad.
so we're 7 degrees south
Here,
of ecliptic.
let's do 5.
So that's the equator.
There we go. I just
And
needed
yeah,
more. So -5. It's about -7,
yeah,
actually.
yep. So
So
it's
definitely
pretty
gonna have
close
some
enough.
influence.
And yep, so just because coronal hole does not align with us, remember that
Oh
this
yeah,
is fast wind,
irrelevant.
so it spreads out.
Right.
It will clip us. There is
Diverges to
also
infinity.
something that I can share from the solar orbiter and solar orbiter data, because solar orbiter actually saw a shock. It
Okay.
saw a CME. There was a CME.
Green is yours.
Aye. All right. So this is where solar orbiter is right now. So it is sitting about, oh, interesting. So it is at 6 degrees. I think it's still, yeah, it's still slightly east of us. So it might see some events a little better. And it is definitely south of us. So there is now about a greater than 4 degrees difference. It's still close enough, but for some events, like we're talking about CME from, I think, March 7th, that was mostly propagating southeast.
Mhm.
Solar orbiter is still in better position to see it.
Yeah,
So let me find solar
it's a decent
orbiter.
southward amount.
Yeah, if you want to cover that, but I can take a look at the solar orbiter. If it shows it to me. Yeah. So there is a little bit of a shock right there. It's a rapid change. So shock means many different things in physics. And from the magnetic perspective, again, it's a change in magnetic strength of magnetic field. So that's the total magnetic field change. And it jumped quite a bit. We're not going to see 30 nanotesla. Solar
Right.
orbiter is a lot closer to the sun, so by the time it reaches us, it's gonna be significantly diminished. But then it probably started to see coronal hole a little bit too, right over here. So we'll see how it evolves over the course of the day. So we may see more of a combo event coming, probably at lower strength
Yay!
compared to what we're seeing here. But it
Yeah.
is, yeah,
Good
next
enough for
week for
Alaska.
Alaska, it definitely will be good. I am not seeing much of the flux rope here, so it may have been a glancing blow even for solar orbiter. And because it's already at 11, like it's separated, our separation is 4 degrees. So it's clipping solar orbiter. It's hard to know what it means for us. It does reduce our forecast uncertainty just a little bit, but still not enough to be sure like, sure this will hit us. Coronal hole will hit us. That
Yeah.
CME, not so sure about it. Have to wait and see. But it may arrive as more of a combo event because the speed in solar orbiter is not that great. It was a slow one.
Okay.
So coronal hole can probably catch up and sort of bring it
Yeah, I've
over.
always,
And this
that's why
is
I've always
what
liked,
happens
yeah.
sometimes with flux ropes if they're riding ahead of fast solar wind. They can be compressed and heated. So the typical drop in the core temperature for some of the flux ropes that we see embedded in the fast solar wind, they may not give us that drop, and they may be more of a dense things because again, normally we see flux ropes as a core of CME. They're cooler. They're not like significantly cooler. They're still pretty hot things, but they're also less dense. And if there is solar wind that's kind of pushing from behind it, fast solar wind, it will compress it. And that's what shocks kind of do. They compress things. So it's not like a shock wave traveling all the time. It's sort of a region where we see a change in density and magnetic strength. That's what we call shock.
Awesome.
Fun.
But
We'll see what
yeah, fun.
happens.
But this is
Yay.
why I'm like, this is why I always kind of like coronal holes. Like they're just more predictable.
Yeah.
Yeah, more guarantees, but yet
Either,
you still have a nice variability to where it could be still
yeah,
way better than expected or
yeah,
slightly worse. But you're expected to get something.
yes, something. Something.
Something.
So, but I think that's,
That's everything I got.
is that our agenda for the day? I think it was.
That it was.
Stuff like that. I
Yeah.
would
Time to pack.
show some pictures from last night, but I didn't download them, so Wah wah.
Okay. I think most people here follow your Facebook at
Yeah,
least.
you'll
So
see it eventually. Maybe I'll download it when I get off here, maybe not, because I'm kind of tired, but it's all good. But we wanted to get a stream in because last week we did Aurorasaurus. So we kind of took that week to volunteer for that particular event, which is why we weren't here last week. So we wanted to, rip off another one for those that
yeah,
are here to watch us.
And on that note, if you saw Aurora and photographed Aurora, your reports are always welcome on
Yes.
Aurosaurus.
Aurorasaurus.
So please report.
Particularly for complicated events like we had last night, where the substorm was no go several times. All of those breakups where beats happen and then substorm doesn't come. That's actually very important to understand what our magnetosphere is doing. So those observations are really helpful.
Yeah, it is. So that's our Aurorasaurus plug of the day. So I was just looking at some of the questions because and Christian got it too because the CRM impact happened. But
Your comments come up way late for me.
yeah.
I always answer
So
after you do.
yeah, so this we're in this particular high speed stream, but we have the next one coming. So we had a couple
Yeah,
days.
like the 12th, early the 12th UTC, I'd
Yeah.
say would be around the expectation time for me.
Yes, I think the Huxt Fordcast or whatever had it around 12 or
Yeah.
March 12th, something like
Yep.
that. So, which is
And
pretty
what's
much on.
interesting, it
Yeah,
has that CME forecasted just before
right.
we
So
start to see the stream.
it'll be
That's like
interesting.
right on my plane towards Fairbanks too. Just saying. Now let's hope I remembered my lens hood, the rubber lens
Mhm.
hood for the windows.
Remember, no tripods. Tripods are bad.
Yeah, yeah, I've given up with that.
That's
12,800 ISO
so
instead.
I'm just gonna preface so like you'll probably hear anybody that follows my page or whatever. I'm probably gonna put some Mark Adamus isms out there because he's such an interesting character. But one of the things is he hates tripods. He hates them with a passion because they hinder his ability to move. So night photography is a challenge for him because he doesn't like to use tripods, but he will use it for night photography.
Because you're
Um,
not supposed to move.
yeah, but yeah, and I got yelled at a few times for not following the moonlight and doing what I was supposed to do. So it was fun. It was fun. But yeah, so tripods, he doesn't like tripods. So I'm gonna use that as an inside joke from here and there. But anyway, it's great. Let's see if we have any more questions to attest to, but it looks like I think we
Question
got them all.
on nitrogen fringe. So,
Oh yeah.
let me actually,
If you have a picture available, that it's
oh,
easy to show the picture.
I wish I had a good picture.
Yeah,
Yeah,
I think I
I'm
posted
sure.
one of mine recently, so I'll pull that
Let me
up.
see if I have one. I don't. Yeah, you pull
Whoever
yours.
gets it first.
Yeah, whoever gets it first.
Just
I'm on
share.
my,
That'll be the buzzer button.
yeah, I'm on my laptop that I don't have much on here, so whoever grabs it first.
Found it.
Okay, Christian has it. Christian,
Yay.
you win. Share
This is
it.
personal Facebook, and this is actually, I believe the
Yep.
person that drove me to this trip is watching, so hey. But yes, the
That's,
pink there,
that's
and
my
honestly, this is probably too ironically slow of an exposure, even though it was like 1 second maybe. Literally, the snow. Just to preface this, there was no moon, there was no lights. You could see like it was daylight in this very easily. That's how bright it was. The pink though edges. So we're talking nitrogen fringe. It's literally the heavier nitrogen, since nitrogen is at least it gets denser in the lower atmosphere. This is what it glows when it's energized from the precipitation coming down. But it's not, it doesn't look like just a band. It's these just fringes that they dance, they move across, and they're so fast that it's really hard to accurately photograph, at least in my book, because I haven't quite yet. And so it makes it look like just a pink band, but they're pink lines that move really fast across the bottom of that. And
I
it
actually,
makes it look like it's coming down to earth, like it's gonna just fall down and beat you. That's my favorite way to describe it.
and I
Yeah,
have a breakdown for the species that glow, so to speak, and for the height where they form, so I can share that picture
yeah, do
to
it.
explain why we call it why it's called nitrogen fringe. So this is the picture. This is when we see reds that's high
Yep.
altitude, and you need a substorm to really move lower energy stuff and kind of just basically park them and have them meet oxygen. So it's atomic oxygen. You see more of a green yellow kind of at the lower altitudes, and then you get two nitrogen, so it can make different colors. And actually, Christian, you had a beautiful photo that kind of shows that breakdown of
That
color,
structure,
a
yeah.
mixture of the two.
Yeah.
But it's neutral gas, so it really is N2. It's a molecule, so it's a molecular species, unlike everything else, which is more basically neutral
Atomic.
it's atomic oxygen mostly flows. But yeah, you get the picture. So different heights and different species, when they encounter raining electrons of Aurora, they glow in different color.
Which also kind of backs up why it's very rare to see this in mid latitudes or even lower latitudes. It's very low altitude that this is occurring, which means literally it needs to be overhead. And by then, those storms, as we saw in May and October, usually have a lot of red too. So you see the giant red pillars instead of the pink fringes. I don't know. I assume they exist simultaneously, but I've never encountered a situation where you could see both the red being giant and the pink. I assume Arctic levels would see that, but
Yeah, and you may end up seeing something more like a continuum emission where it's all colors blended into
that
one.
makes
So
sense.
it's a possibility that you're just seeing up into Corona and you see all colors together. So you really need more of an isolated band of green that's already glowing and pretty energetic particles that are going all the way to the lower altitude. And to see it to mid latitudes, it's going to be difficult because you have to push Auroral oval that far away from the pole, and it has to be still kind of more of the isolated band to get that going. So it's a challenge, but
Mhm.
we saw it last night. So yeah, it's beautiful. I'm a fan.
Yeah, once you see it, it's a very cool thing to see. So and Lisa says, yeah, she sees them up there. Yeah, yeah. So it's cool. So anyway, there's our
All
little thing
right,
on. So on that note,
time to go pack.
yeah, we'll
I have
let you
not started.
Awesome.
go. So thanks for joining. Thanks for watching as always. And I we'll probably do one next week too. We'll decide what
We'll
to
still be
do.
in Alaska then, I want to
Yes,
say.
And
but
I'll be packing for Boulder.
And then
yeah,
yeah, we'll do
I'll be
Boulder
right.
the
in
week
Boulder
after or the day
actually.
after.
I will be in Boulder. We're doing it on
That
Sunday.
Sunday.
I'm gonna be doing it from, yeah, that's Boulder.
Oh, okay.
So it'll be fun.
So we'll all be in different places.
Yay! All right. Well, I'll let you all go. Thanks for watching as always, and
Yeah, everybody.
we'll see